Hi, in this video we are going to be solving logarithmic equations. So the first question says 2 times log to the base 8 of x plus 2 is equals to log to the base 8 of 2x plus 19. So we are going to be applying the laws of logarithm that we have studied, and we are going to be solving for the values of x. The first step that should come to your mind is to take this 2 as a power of x plus 2. So using the power rule, I can express this as log to the base 8 of x plus 2 square, which is equals to log to the base 8 of 2x plus 19. Now if we look at the left hand side and the right hand side, log to the base 8 of this value is equal to log to the base 8 of this value, which indicates that the two values x plus 2 the whole thing square and 2x plus 19 must have been equal. That is why their logs have the same value. So therefore we are going to conclude that x plus 2 the whole thing square must be equal to 2x plus 19. Now we are going to solve this algebraic equation. X square plus 4x plus 4 equals to 2x plus 19. It reduces down to a quadratic equation, and the two values of x can be calculated using either middle term breaking or quadratic formula. So the two values of x came out to be 3 and negative 5. But we are always going to check our answers. X equals to 3. Let's check x equals to 3. If we plug in 3 in this equation, the log is defined. So log is defined for a positive value. So this value must be a positive number. So we need to select that value of x which is going to give us a positive value, because logs are only defined for the positive values. So plugging in 3 over here will make it 5, and plugging 3 over here will give us 6 plus 19, that is 25, again a positive number. So yes, x equals to 3 is the correct answer. But x equals to minus 5 will make this number negative. So we are going to neglect this value. So the only answer is x equals to 3. The next example is 4 times log to the base x of 2 minus log to the base x of 4 equals to 2. So first we can take that 4 value as power of 2. So we can express this as log to the base x of 2 to the power of 4 minus log to the base x of 4 equals to 8. Now using the division rule, we can express this as a single log, which is going to be 2 to the power 4 upon 4. Now 4 is basically 2 square. So using the rules of indices, we can simplify this further down, which is going to be log to the base x of 2 to the power of 2. So log to the base x of 2 square is equals to 2. So if we convert this into an exponential form now, x to the power of 8 is equals to 4. 2 square is 4. And to find the value of x, we can take the power of 1 upon 8 on both sides. So x is equal to 4 to the power of 1 upon 8, which is around 1.189 to 3 decimal places. Okay, let's consider another example. 2 log 2 of x square plus 5 log 2 of x square equals to 72. Now what we can do over here is we can substitute log 2 of x for any variable, and this is going to help us reduce down our complex equation. So over here we are going to consider x square as x to the power of 2. So 2 log 2 of x square plus 5 log 2 of x square. We can express x squared like this as well. Now this power, using the power rule, we can multiply 2 with 5. So 2 times log to the base 2 of x square plus 10 times log to the base 2 of x equals to 72. Now we can substitute, let's say y equals to log to the base 2 of x. So our equation becomes 2y square plus 10y equals to 72. Reducing down this quadratic equation will give us two values of y. The y value comes out to be 4 and minus 9. Now we don't have to solve for y, we have to solve for x. So y was actually substituted for log to the base 2 of x. So log to the base 2 of x is equal to 4 and log to the base 2 of x equals to minus 9. So to find the value of x, we will have to convert this into exponential form. So x is going to be equal to 2 to the power 4, which is 16. And x is going to be equal to 2 to the power of negative 9, which is 1 upon 512. Both values are positive, so they are accepted. These are the correct values. Thank you for watching this video.